All right, welcome back. We're going to pick up where we left off from part 1 video. So we're looking at number 3, letter B. It asks us to do division now, and you do f of x, that's this big polynomial here, 15x cubed minus x squared plus 13x. And I'm going to divide that by g of x, which is 5x minus 2. Okay, so I could do this with long division. I could also use synthetic division. I'm going to go ahead and do synthetic division because I find it easier. So we need to figure out what number goes in the box. So you're always going to take the thing you're dividing by, set it equal to 0. I get 5x equals 2. So x equals 2 over 5. So that's what goes in this box here. It's 2 over 5. Now for synthetic division, I need to put the coefficients on the right side. So let's start in order. We have 15, and then -1 for our x squared, 13 for our x, and notice we're actually missing a constant term, so we need to put a placeholder for that. There is usually like a +5 or -6 at the end. Here we don't have that number, so we need to put the 0 at the end as a placeholder. Okay, so we're going to be very careful now since we have a fraction in the box. So let's bring down our 15. Now on the side, I'm going to show the work. I'm going to do 15 times 2 over 5. Put this over 1 and multiply across. That gives me 30 over 5, which is 6. So -1 plus 6 is 5. And I'm going to multiply again. 5 times 2 over 5. Put it over 1 and multiply straight across. 5 times 2 is 10, over 5 is 5, and that simplifies to 2. So 5 times 2/5 was just 2. Again, 13 plus 2, that's 15. Hey, we already found out what 15 times 2/5 is. Right, that was 6, that was from over here. So I can just use the calculations that I already did. And now adding straight down, 0 plus 6 is 6. Remember, that last number is our remainder. So the answer to this division problem, we have to remember, before we start writing 15x squared plus blah, blah, blah. No, we have to remember to divide by that denominator there. So we have to divide every term by 5. So we're going to get 3 instead of 15 over 5, we get 3. 5 over 5 becomes 1, and 15 over 5 becomes 3 as well. And our remainder is 6. And now we just have to drop our powers. So if we started with an x cubed function, that means that here we have 3x squared plus 1x plus 3. And our remainder is plus 6 over the thing we were dividing by. That's 5x minus 2. That's our answer. Okay, let's move on to the next question. Number 4. It says factor the polynomial and identify the roots. So look briefly at number 4. Compare A with B. Why might we do A and B differently? Well, in the case of A, we're dealing with a quadratic function, right? Our highest degree, or our highest power is 2. So this would not be a good way to do the problem. Plus or minus 1, 3, 5, 15 over. This is not a good way to do this problem because we actually know how to factor polynomials when our highest degree is 2. This is a quadratic. We use our magic X. Okay, we need two numbers that multiply to -15 and add up to -2. Those numbers are -5, +3. And so we can simply rewrite this as x minus 5 times x plus 3. So when it says find the number of roots, well, if I actually had to find the roots, I would set this equal to 0, and I would get 5 and negative 3. But the question doesn't want me to find the roots. It wants me to give them the number of roots. Well, I have 2 roots. That's what I'm going to write, because those 2 roots would be 5 and negative 3. Now here's the neat thing. Every time that we have a quadratic, x squared plus anything, 6x minus 11, 5x squared minus 100x plus 6, like, doesn't matter. As long as my highest degree is 2, I will always have 2 roots. If my polynomial has a highest degree of 3, then I'm going to have 3 roots. Okay. So make a note to yourself right now. You should know this as you approach these problems that ask for the number of roots. The number of roots is always equal to the degree of the polynomial. What does degree mean? It means the highest exponent, or the highest power. This is super important for the rest of this problem, and also you'll see it in number 5. So whenever we're talking about the number of roots, just look at the degree of the polynomial. Our degree was 2, so we have 2 roots. Let's look at b. Our highest degree for b is 3, so we can automatically say 3 roots. So we answered the second part of the question, which is how many roots, but we still need to factor it. So obviously we can't use magic x here. Magic x is only for quadratics. Here we have a cubic function, a power of 3. So we approach this, we have to test different roots and use synthetic division. So we have to come up with that list first of all, using the rational roots theorem. So plus or minus, we're going to put all the factors of 30 on the top, and all the factors of our leading coefficient, so the number in front of x cubed, which is 1, that's going to go on the bottom. So numbers that multiply evenly into 30, that's what I mean by factors of 30, are 1, 2, 3, 5, 6, 10, 15, and 30. And the numbers that multiply to give me 1 are just 1. Well, if I'm going to rewrite this, 1 over 1 is just 1. 2 over 1 is just 2. 3 over 1 is just 3. So anytime I just have a 1 on the bottom, I can kind of like, short circuit the process and say these are my possible rational roots without even worrying about the denominator. Now I'm going to start testing them. So let's start with positive 1. My coefficients are 1, 4, negative 11, negative 30. And I'm going to use synthetic division to test. Okay, so this one didn't work out. Positive 1 did not work out. Let's try negative 1. So bring down the 1. 1 times negative 1 is negative 1. I'm just zooming through this because I already know that we're going to have to do it a few times. So this one didn't work out either. Remember, I'm looking for a remainder of 0. These are not remainders 0, so I have to keep trying different roots. Now we're going to try positive 2. Feel free to pause the video, try it yourself, and then check. Again, didn't work out. Let's try negative 2. So bring down the 1. 1 times negative 2 is negative 2. 4 minus 2 is 2. 2 times negative 2 is negative 4. Combining these, that gives me negative 15. Ooh, and negative 15 times negative 2 is positive 30, which is great because negative 30 plus 30 is 0. So we got a remainder of 0. That's great. That means that if negative 2 is what was in the box, that means we really divided by x plus 2 and got a remainder of 0. That means x plus 2 is a factor. Well, if it's a factor, that means x plus 2 times something will give me the original expression at the top. So I'm going to go ahead and rewrite p of x as a product. So this whole thing can be rewritten as the product of x plus 2 times the answer that we got. So we just have to drop our powers really quick. That's going to be x squared plus 2x minus 15. And I believe we're asked to factor it all the way, right? Factor the polynomial. So we have to continue factoring. We can use magic x over here since we're now dealing with a quadratic. So we need two numbers that multiply to negative 15, add to positive 2. 5 and negative 3. So x plus 5, x minus 3. And we have finished our factoring process. And we already answered the question before, but we had said 3 roots, remember? Because of the cube as our highest degree. And we can confirm that. If I was asked for my roots, I would say negative 2, negative 5, and positive 3. That's 3 roots. All right, let's do 4C now. Okay, so this would be done like problem B, not like problem A. So we're going to list out our possible rational roots. So we got plus or minus 1, 2, 3, 5, 6, 10, 15, and 30. Those are all the factors of 30. And now we need all the factors of 1, which are just 1, so I'm not even going to write it. Cool. Let's start testing. It's always good to start with positive 1. So our coefficients are 1, negative 6, negative 1, and positive 30. It's always important to check. It's always important to check and make sure you're not missing any terms. I have my x cubed, my x squared, my x to the 1, and my constant. So we're not missing any terms. We don't need any placeholders. All right, let's bring down the 1. 1 times 1 is 1. That's negative 5. Negative 5. That's not working out. Because that's a remainder of 24. Meaning 1 is not a root. That means that x minus 1 was not a factor. Let's try another one. Let's try negative 1. Let's bring down the 1. Positive 7. Also didn't work. So that means we just found out that x, flip that, x plus 1 also not a factor. Let's try another. Let's try positive 2. Not working. Not a factor. Gosh, this is a lot of work. So now we're trying negative 2. Oh my god, I think it works. Okay, so then 15 times negative 2 is negative 30. So go ahead and try negative 2 yourself and just make sure it worked for you. So we just discovered that finally x plus 2 is a factor. So we're going to rewrite p of x as the product of x plus 2 times this answer. Goes right here. X squared minus 8x plus 15. As before, we're asked to fully factor, so we need to continue. We'll do magic x over on the side. And those numbers that multiply to 15 and add to negative 8 are negative 3, negative 5. So our fully factored version here is going to be x plus 2 times x minus 3 times x minus 5. And we're done. Okay, we took some notes earlier exactly for this question. It says how many roots? Well, we had said the number of roots is equal to the degree of the polynomial. And the degree is the highest exponent, right? The highest power, not necessarily the leading one, the one in front. Because look at A really quick. What is our highest power? If you say 3, because I immediately goes to the first one, you would be wrong. In this case, the 5 is the highest exponent. In fact, this should be rewritten as x to the 5th plus 6x cubed minus 12x. So the number of roots this has is 5. Let's look at B. Any tricks here? It seems that it's actually written in order. It goes from 4 to 3 to 1 to the constant. So our highest power is 4, right? This is a 4th degree polynomial. We will have 4 roots. All right. Number 6 says, list all the possible rational roots. Just list them. So it doesn't say solve. It does not say factor. It does not say check if this is a root. Like, there's really almost no work to do. We just have to list the possible rational roots. So that means, well, what are the possibilities for your numerator? What are the possibilities for your denominator? And now list them all out. So our numerator will be all the factors of 10. That's going to be 1, 2, 5, and 10. And our denominator, you got to be careful. We're not going to use the 6 here. Why do you think that would be? That 6 doesn't actually belong in the front. If you notice, our highest degree, again, is the x to the 5th here. So this is really out of order. So our leading term is really what's supposed to go in the denominator. In this case, it's not 6, it's the 1. I should rewrite this. In fact, you should rewrite this every time you see it on the test or in your homework. That's much easier to understand. The 10 goes in the top, and then the 1 is in the bottom. And as we've said before, when we just have a 1 in the bottom, we can just rewrite it like that. Cool. All right, 6b, same thing. List all the possible rational roots. So we're going to do plus or minus using our rational roots theorem. The factors of 14 are 1, 2, 7, and 14. And then the factors of the leading coefficient are just 1 and 23. So here we actually have a little bit of work to do. We've got to try every numerator with every denominator. So here's how I like to do it. I'm going to focus right now only on the 1. So let's put every numerator and match it up with the 1. And then we'll move on to the 23 next. So my options are, my possible rational roots are plus or minus 1 over 1, which is 1, 2 over 1, 7 over 1, and 14 over 1. Done with the 1. Let's move on. Now we're going to pair them all up with the 23. So that's going to be 1 over 23, 2 over 23, 7 over 23, and 14 over 23. Notice that none of these actually simplify, so I have no repeats. So this is the final list of my possible rational roots. All right, moving on to number 7. It wants me to find the volume of a rectangular prism. This is what a rectangular prism looks like. Okay, given the following information. So for volume, we need the length times the width times the height, and that's exactly what I'm given. The length is 5x, the width is x minus 3, and the height is x plus 3. All I have to do is multiply them together. So I'm going to rewrite this as volume equals, my length was 5x, my width was x minus 3, and my height was x plus 3. Now something that I like to tell my students is when you're multiplying 3 factors together, it's usually easier, in my experience, to multiply the last 2 first. So I'm going to go ahead and FOIL this out by focusing only on the last 2, and then we'll deal with the 5x later. So let's rewrite this. That's 5x times, and let's FOIL this in here. X times x is x squared. X times positive 3 is plus 3x. Okay, so I just did this and this. Now I'm going to do negative 3 times x is minus 3x. And negative 3 times positive 3 is minus 9. Now before you get all distributing crazy and go all in over here, remind yourself to always see if you can combine like terms inside your parentheses first. And in this case, 3x combines with negative 3x and they cancel each other out. So I'm actually saving myself a whole buttload of time by combining my like terms. So rewrite this. That's 5x times x squared minus 9. Now we can finally finish and distribute that 5x in. That's 5x cubed minus 45x. And that would be our volume. Okay, we have just a couple more. Let's look at B. So in this case, instead of giving me length times width times height, they're giving me something different. They're giving me the height, and that's awesome. Instead of the length times the width, they're giving me the area of the base. Well, let's have a quick look at what the rectangular prism looks like. In the last problem, I had my length, I had my width, I had my height. This time, they're giving me the area of the base. Well, have a look. How would I calculate the area of the base? The area of the base is really nothing more than length times width. So if I want the volume, instead of doing length times width times height, I can just rewrite that as area of the base times height. So I'll call that A times H. So that's cool because they gave me everything I need. I just need to multiply this, the area of the base, times the height. So let's write it out. 2x squared plus 5x minus 6 times x minus 4. Now in my classes, if I have a trinomial times a binomial, I like to put the one with two terms out in front. For me, that's just easier. So I'm going to rewrite this x minus 4 times 2x squared plus 5x minus 6. And that's okay, right? We can multiply things in any order. For example, 3 times 5 is the same as 5 times 3. It doesn't matter the order that you multiply things in. So for me, this is easier because I can now focus on my x term and take care of that. So it's going to be 2x cubed plus 5x squared minus 6x. And now I will separately focus on the minus 4 term. So minus 4 times 2x squared is minus 8x squared. Notice how I'm stacking it with the like terms. So I'm already kind of joining them. It makes it easier for later on when you're combining your like terms. So minus 8x, and then minus 4 times 5x is minus 20x. And minus 4 times minus 6 is plus 24. Now I'm just going to combine my like terms by adding downwards. So that's 2x cubed. 5x squared minus 8x squared is minus 3x squared minus 26x plus 24. And that's our answer. Can you believe this? We're on the last problem already. It says write an equation for this graph. So let's have a look at what we got going on. When we're asked to write an equation for a graph, the first thing we should look at are our x-intercepts. In this case, we've got 3 of them. And it's helpful to write them out. So at x equals -1, at x equals +1, and at x equals +4. So given that these are my x-intercepts, we can start writing our function based on the factors that these would have come from. So to get an x-intercept of -1, that means our factor should have said x plus 1. So we're flipping the sign of the number. For x equals 1, well, that must come from a factor that says x minus 1. And the last one would be from x minus 4. So we have kind of like a start. Okay, we're off to a good start. But there are a couple things we need to watch out for. The next thing we're going to pay attention to are our exponents. our exponents, if we are crossing, at that point, the exponent should be odd. If we're bouncing at that point, our exponents should be even. So let's have a look at what's happening. Now this is a little tricky. It says x plus 1, but we should not look at positive 1 because the x-intercept that x plus 1 gives us is negative 1. So you need to make sure you're looking at the right place. So to figure out what the exponent is going to be here, we should look at the behavior at x equals negative 1. It's bouncing. That means we are going to have an even exponent. So maybe a 2 or a 4 or a 6, doesn't matter. Or 108 would be fine. Okay, let's figure out for our x minus 1 factor. Okay, for x minus 1, we should examine the behavior of the graph at x equals positive 1. It's crossing. That means that we need an odd exponent, so maybe a 1. So if I don't write anything at all, that would be fine because that means there's a 1 there, right? An invisible 1. But I could just, be silly and put a 9 or a 7 or any odd exponent would work, or a 3. Okay. Now let's look at x minus 4. So we're examining the behavior of the graph at x equals 4. It's crossing, so we need to be odd. Let's make it a 3. Of course, you could have made it like this. X plus 1 to the 4th, x minus 1, x minus 4. Now that would be cool too, because as long as I have an even exponent here and odd exponents on the other two, we're good to go. So let's apply the same rules to our last problem of the day. It says write an equation. Now it's not exactly super clear, but here we have 3 x-intercepts. At x equals negative 3, at negative 2, and at positive 4. So we're going to write them out like before. From our x-intercepts, we're immediately able to get the factors of our function. So it's going to be x, remember to flip the sign, plus 3, x, flip the sign, plus 2, and x, flip the sign, minus 4. Next, we have to pay attention to our exponents, okay? So examine the behavior of the graph at x equals negative 3. It's crossing, so odd. Next, at x equals negative 2, we're crossing again because we're going from down here. It's not super obvious, but we are crossing and then crossing again. So another odd. And at x equals 4, we're also crossing. Oh my God. So this would be perfectly fine as an answer. X plus 3, x plus 2, x minus 4 with no exponents at all because it would be 1, 1, 1, which are all odd, and that's good. But there's one thing that we have to worry about, and I didn't mention it in the last one, but I'll mention it here. Unfortunately, this is the wrong graph, okay? What we have just graphed is actually this function. Why? Because it's positive. It's going up at the right end. That means that there's a positive out in front. And that's the graph that we gave. We didn't put out anything out in front. That means it's going to be positive to the right side. But our graph is actually negative on the rightmost end. It's going down. Well, we should reflect that in our answer then by putting a negative out in front, right? A negative out in front. So both of these would be good answers. Here's yet another good answer. Negative 5. Like there could be a number out there. As long as you're not adding an x out of nowhere, because that would be another x-intercept at 0. You want to just put a negative out in front. A negative number is cool too. And then again, you can put any odd exponents that you like. These are 3 different possible awesome answers. So, in this case, let's see if we were okay not putting anything out in front. So for this graph, on the rightmost side, it's positive. That means that we should have a positive out in front of our answer. Hey, since we didn't put anything out in front, that automatically means it's positive. So we're good to go. All right, I hope that was helpful. Let's stop the video.